discussion that's about to take place. A little background, while additive manufacturing is also called 3D printing, it's gained a lot of attention in recent years. These technologies really have been around for over 20 years. It's no longer an emerging technology. Additive manufacturing is leading industry innovation. From design to prototype production parts, additive manufacturing technologies and processes help conceive, test, improve, and manufacture new products, bringing them to market faster and most cost effectively. Today's panel experts will discuss current and future issues via case studies and research and development activities that continue to advance the applications of additive manufacturing and 3D printing for the oil and gas industry and beyond. It is with my pleasure to introduce Mr. Kevin Ayers, SME's Industry Manager of Additive Manufacturing and 3D Technology and moderator for today's panel discussion. Thank you.
Well, before I get started, I wanted to encourage you guys to stay afterwards so that we can network with you. We're defining the role of additive in this industry, and there are a lot of people involved in additive or starting to get involved in the additive energy industry. We want to start forming a network to collaborate on problems that we all share. So thanks, Kathy, for the introduction. Prior to this position with SME, I have over 30 years experience as a design and manufacturing engineer, believe it or not, with the Federal Bureau of Investigation. Most of that time I've spent in additive and plastics, and 7 of those years in metal and additive. So I'm going to introduce the cast, and they're going to give a little bio for themselves, if you don't mind. And then Bill, take it away.
Hi, my name is Bill Macy. Did 20 years with McDonnell Douglas. Is that us? No, machine. McDonnell Douglas in the aerospace industry. We spun a company out to do design services on the digital thread, everything digital, from design through the fabrication, inspection, and reverse engineering. Additive manufacturing became a very large part of that solution set to bring work back to the U.S. and reshore a lot of products that had been offshored before. So we've been taking that technology and deploying it the last 15, 20 years now. We've been perfecting that process for small and medium-sized companies.
Good afternoon, my name is Todd Grimm. I'm a consultant in the 3D printing or additive manufacturing industry. I got involved in 1990 with an early service bureau in the industry. And interesting, my origins out of school were also McDonnell Douglas. However, I went to work for the CAD/CAM side of McDonnell Douglas. That's how I was introduced to the technology at a trade show that no longer exists called AutoFact, when we started reading about this fascinating thing called stereolithography. Caught my attention, caught my interest, as it is for many people today, and I was offered an opportunity to start work with a small startup, absolutely no pay for the promise of a grand future, and I've been doing it ever since 1990, consistently for the last 25 years, 12 of them with service bureaus, and the last almost 13 years on my own as a consultant.
My name is Barry Calnan. I'm with 3D Printing Solutions here in Houston. And we are a subsidiary of an oil and gas services company, which makes us a little unique in the 3D printing industry. We specialize in helping people more with design intent and then down to actual 3D printing of objects. Not necessarily direct metal, but we do actually have some direct metal machines that we deal with on a regular basis. My background is about, I guess, 8 years ago working for Halliburton. I became very interested in 3D printing for actual end-use product. Worked with them on a few patents specifically for end-use product design and manufacturing. And that's how I became very interested in the technology. Turned out that several years later I went out and actually became a reseller for 3D Systems, or Z Corporation, and have been doing that for the past few years under the parent company Subsea Solutions here in Houston.
Okay, format for this is I'm going to ask some general questions, and then later on we're going to open up for you guys to ask questions, broad or specific. It's up to you, whatever you have on your mind, and then we can help you with your own company, your own applications. So I'll go ahead and start it off. Gentlemen, in regards to the energy industry, where's additive manufacturing being used now? Anybody want to?
I'd like to have you lead since you've
Sure.
been actively involved.
With the oil and gas industry, it's been one of the slow adopters. I've found being a reseller in the past 8 years, the companies like GE for turbines, things of that nature, have far eclipsed any of the work being done in the oil and gas industry. A lot of that has to do with sheer size of equipment, the type of materials involved in 3D printing the objects that an oil and gas industry company would want to print. The other issue is really oil and gas and energy industry manufacturing is a very slow industry to kind of change and move in a different direction. You have to really start working from the engineers and the designers, teach them how the tool works so that the final end-use products can be more innovative. There's no reason to change and print a very large piece of metal that can be manufactured in a standard way. You're just replacing one tool with the other. What's important and what's exciting about this in the oil and gas industry is being able to recreate something using limitless design applications so that you're not limited by tooling, you're not limited by a single material in a single, if you want to call it a casting or a print. You can use multi-materials, you can use design interior fluid flow, you can do, it's limitless. It depends on the designers, but you've got to open their minds first of all to be able to get the pieces of equipment that are going to be used in the future, I think. As far as where it is today, unfortunately, I think we're just on the cusp of a lot of the major players starting to dabble in 3D printing. A lot of them have tried in the past, and because, unlike the gentleman over here, I mean, I deal with customers that are working with desktop units that they bought online to $1 million units that they'd have to go through a certain vendor for, either Stratasys 3D Systems or various other EOS. What I see happening is they buy too little of a machine and get burnt because it can't produce the parts that they're looking for it to produce. They don't have that knowledge, they don't have that background that we've been talking about, where you need to understand what the tool can do and how it can make the parts that you're looking for. And it may not make the entire part you're looking for, but it certainly can be incorporated to do things that you could never do before.
I'll take a little different tack at it. Coming up out of the evolution of this technology, it came from prototyping. It was good enough materials with good enough systems that made good enough things to communicate. And as the materials have improved and the machines have improved, we're starting to move into what we call additive manufacturing. And they are different. 3D printing is the technology at large, and additive manufacturing is the more disciplined process of we know how to engineer it, we know how to manufacture it, we can do it repeatedly, and we can do it with inspection that certifies that that part is a qualifying part. That's a much different challenge than what has been done to date. So as we move down this path, we really need to understand how we're leveraging those technologies and maturing them such that everybody knows how to play this game. It's a very early in the manufacturing side of this sector. We understand very well the value proposition of parts consolidation, improved performance with reduced manufacturing restrictions. Those things we understand, but we don't have all the manufacturing processes and material factors and design procedures and software we need to fully realize the benefit of this. That's why we're seeing these little pockets of knowledge, little pockets of success stories erupt, because somebody's put the time and due diligence to go get that, whether that's internal R&D or personal expertise, doctoral thesis. Those are the kind of erupting knowledge points we have today. What we see coming into the environment, though, is machine centers like those on the floor here are now picking up tool heads that will come in, integrate with those machines, and take advantage of the technologies that we've been developing. This will make the first major improvement in your options on how you're making parts. We're going to see them as hybrids at first. You'll have traditional materials that are commodity materials that you know how to use, and then you'll add features onto that that add the supreme value or the extra performance that you're going to get. So I encourage you to start thinking about how these environments and these technologies will play into your product, your offering.
Ditto. No, just kidding. Try to build off of both the comments. So I absolutely agree on oil and gas that not moving all that fast is my perception. I don't know the industry as well as Bill does, but my perception is you're moving slow. However, I want to back off of that just a little bit. There are exceptions throughout all industries where we have innovators pushing the technology, but usually it's a couple of key companies, like Bill indicated, that have made that investment to do something different, to tackle this new technology. And it's not true across all industries. So I don't want you to walk out of here feeling bad that we're oil and gas and we're moving like a snail's pace. You're moving at maybe slightly slower than other industries. So I don't want to put too much pressure on you, but I also don't want to take that pressure off of you. The time is now to at least start investigating the technology and asking the question, what could it really do for me? How can our company benefit from it? How should it be deployed? What do we need? What do we need to control? What standards do we need? All of that. So you need to start looking hard now and asking the questions. Also indicated or noted was the design aspect of things. Big challenge that we've set up for you in the industry is freedom of design. Anything you imagine, you can create, you can produce, you can manufacture. Mostly true. There's some big asterisks on that and caveats. However, as an industry, we're giving you absolutely no guidelines on how to do that. Hence, you turn to an organization that's got those skills. So in my experience, the technically minded people want to start off with guidelines in a rule set that they can break. But point me in the right direction. What should I be doing? Instead of saying, clean slate, blank slate, sky's the limit, go wherever you want to go, the gears kind of grind to a halt. The smoke comes out of the ears and like, help me get started. We're not giving you that. And then as Bill mentioned, we're talking about this evolve from prototyping into manufacturing. One of our biggest hang-ups, and a couple of conversations in the SME booth earlier with oil and gas, and one of the big hang-ups for all industries is we lack standards, we lack certifications, we lack qualifications, we lack guidance for you. So for you to say, I want to do that valve body, that component of a rig, on and on and on, you can't build off of a standard set of information and say, okay, that's been vetted. I'm going to build off of that. What we're asking you to do as an independent company or collection or collaboration, as Kevin was talking about, we're asking you to do that all on your own dime. Yeah. So one of our poster children, what I'm really going on. Wind me up. I'll wrap up with one comment. So one of the poster children of success we have is out of the aerospace industry because it's getting so much media attention, and that's GE, who will be manufacturing a fuel nozzle for the next generation LEAP engine starting in 2016 in Auburn, Alabama. It's a fantastic story. We will be flying on additively manufactured parts. However, the backstory of that is GE started on this journey about 12 years ago and has many millions of dollars invested because there weren't the standards, there weren't the material certs. Well, even starting with material certification, they had to spend all of their money to build any baseline to get it qualified. So we're asking a lot of you. And with that, I think it means that your organization has to see a tremendous amount of value in order to make that investment to go forward. And you as an individual or someone within your department is also going to have to make an investment because without a champion, it will fail. Find someone who's willing to take the risk, find somebody who's willing to wave the flag at every single meeting, then you have a hope. Well, we're asking a lot of you. So it may not be tomorrow for you, for manufacturing, but at least keep your eyes on it as an organization. Don't take your eye off the ball based on what we're saying. Now we'll stop, Kevin.
I'll add this part to it. I think that you need to think of additive manufacturing and those processes as just another tool for making things. And part of the advantage that it has is you don't have to worry so much about manufacturability issues and draft angles and non-manufacturable features. That you can make things, exactly like cooling channels that are very complex, in situ inside a solid block of metal. And you need to think out of the block, in order to do that. And that's right. And then I'll bring to you, let's contrast roadblocks in the industry in general to roadblocks that we see in this industry, for example. We've touched on that a little bit, but what do you guys think?
That was the clearest mud.
I can bring it up, but materials versus throughput versus education and information.
Yeah, so I've been, education, information standards, certifications, qualifications. I already kind of hinted at that. You mentioned also, and I just lost it. There was another barrier that you mentioned I was going to reinforce. Size-wise. Yeah. So you have an ideal set of circumstances for additive manufacturing, which is low volume, high value components. That is perfect. That's a sweet spot for us. But aggravating the situation, as you noted, your parts are usually rather big, rather bulky, lots of mass. And for us, the key component of time and cost is how big is the doggy in the window on this one. So we don't care about features. We give that freedom of design.
Right.
So you are saddled with a constraint that other industries may not be. We don't excel at big parts yet. We've got things coming along. Sayaki recently came to market with a machine that's based on electron beam welding. And they'll build you a custom machine is where I should go. They've got a custom machine that'll build a additively manufactured part out of some pretty exotic metals that's over 9 feet long. They're going after aerospace, and it's wings parts. I should let you talk to this because you probably know more than I do. So we've got challenge of size added as a burden for you on top of the others that other industries experience. Stuff that generally no.
Well, Todd, I think you're right on. The challenge we see today is people trying to apply it at the part level before it's necessarily all the way to a mature manufacturing technology. Don't miss tooling. Don't miss refurbishment, repair, and rejuvenation of parts. These are the areas where you already have 90% of the commodity there. You're adding on special features or tool feature changes that you can reuse your existing product. So these are areas that we're really seeing today immediate opportunity for the technology. Another interesting thing about it with respect to barriers, we all admit that we don't have the material characterization and the databases that we need to qualify and engineer these. Your tool shop, all you got to do is convince the tooling engineer that it's not going to break their machine and that maybe they're going to get enough parts to justify that mod. You don't have to prove to them that it's not going to kill somebody in use out in the field. So what offers you the opportunity to just put it into play, see how it holds up, get your manufacturing experience, test your engineering design principles and concepts on how you're going to do stress analysis. It'll give you the experience that allows you then to have maturity going into product. And I don't know a company out there that will go to product without maturity of understanding the design process. So think of stepwise progressions that allow you to make baby steps of adoption. It'll help you understand your engineering process, your manufacturing process, as well as your inspection and support.
One of the things that has been mentioned by the panel is it's really I don't want to use phase shift, it's a different way of thinking. Standard manufacturing has its rules, has its guidelines. What 3D printing allows is the opportunity to think differently about creating a part, whether that be a particle or just a small design feature. One of the biggest roadblocks is that step, going from what can be done today and what could you do. Now, materials has been brought up. One of the things that I find with the customers that I deal with is they always say, well, is that material going to match this material? One of the expanding thoughts is, do I need that material? Just because you